Yeah. What? Wait, again. What? I didn't go off by your probably not fair. And what you know about spawn.
Oh, you see me? Là yeah.
What top your
When I was yeah. When I was working like that was so I was working past from school.
and top your let's say when report.
Oh, that is you. Was that?
Why the man are you paying attention? Why? You're done? Ready? Are we integrating the same then? Right, to integrate this J, then we add 1 to the power, divide by the new power, and what else? And divide by the differential bracket. That's okay? Add 1 to the power, divide by the new power, and the differential of inside the bracket, plus C. Right? What about this one here? How are we integrating this, Jacob? Huh? Kind of hot day. What we can do? A third, right? So the problem is whenever you have to the power of 1 underneath, right? Whenever you have to the power of 1 underneath, we're going to have to do, oh, sorry, online. Right? We're going to have to make sure the numerator is the difference of the denominator. If here is 3, you pull 1/3 on the outside. Now we could use what? Ln. Yeah? Kalina, you sure? Looking like the first time you're seeing them, Kalina. Yeah? What we could do is 1/3, Shana. Oh, those who doing pure with the school, remember you had a sign over, right? You had to do it again and sign back up again. Right? Don't forget, right? Right, what about here? What's the integral of that? Here, Shav. Know how to do it. I have to print some rules and give it to all, yeah? I'll keep it here. I'll give it to you every time I come to class. I'll do that. Huh? Just the rules. Just the rules like integration rules.
Oh, yeah.
I mean, I usually bash them on paper and things. What's the integral of this? Tan inverse, right? Tan inverse x. That's okay? Yeah. All right. So if you see something like this sapphire, that's tan inverse. Okay? It's just a quick reminder. All right. Right. So that's a quick review there, and let's do one more. We did integral of normal integration, ln inverse trig, one more. We did 4 last week. Substitution. Ah, bro. SUBST. That's S. Right. Here's the problem, Binish. I'm not telling you what the substitution is. What you would let U equal to. plus 3, whatever inside here, right? Because normally this would be to the power of a half, right? So you can let x cubed plus 3. Yeah, Esther? So Esther, when you reach here, what you do? First thing you will do, Esther, is you will differentiate this. Right? What's the differential of this? Right. Why are we doing that? I said to do it. Because we need, if I make a substitution for u, everything must be in terms of u. Okay? So I'll end up with what? The integral of x squared by the square root of u dot, what is dx? Dx is equal to du over 3x squared. What will happen to the x squared? Cancel out. So you'll get 1 over 3 by the integral of the square root of u. Can we integrate this now?
Yeah.
Get that? Yeah. So we will get 1/3 by u, add 1 to the power, divide by the new power, plus c. So when I flip it up, I'll get 2/9 by u to the 3 on 2 plus c. Right? What do I do with the u? Something to the back, right? Okay, sharp, next one is for you, right? Who do it by H-sharp? Who do it? Jacob? Jacob, right? I'm done. Yeah. No, no more. Try this here. Try number 2. What you let u equals to 2x squared plus 4, right? It's normally what's in the bracket. Baby first. Right? Yeah. This coloring down. Coloring. Color down. Yes.
你刚刚那个上一场的一些名不如这上，还能爱的，因为
Take your time, work it out. Online, develop data. Wait, what we now with feet? I think feet now.
Or go down to the machine that develop. Yeah, yes. But that's.
Now same feet couple. Y'all done? Let's go. Can we get through? Right, feet in orange. So let u equal to 2x squared plus 4. Remember, we have to differentiate it. We have to find du dx. So that will be did I write the correct thing, boy? Anyway, too late for that now. Should still work out. 4x. So when I cross multiply and simplify, I'll get dx to be du over 4x. When I substitute, I'll get the integral of x by u to the power of 5 dot du over 4x. X will cancel. So you'll get 1/4 by the integral of u5 du. Right? You'll get 1/4, add 1 to the power, divide by the new power. So I got 1 over 20 by u to the 5 plus 3.
You see a very educational excellence. I want to know.
Sorry. That's good? So it's 1 over 24 by 2x squared plus 4 to the power of 6. Nice. Here's what. Sometimes you don't have to do all of that. Right? Here's what you can do.
No.
Note that.
So
Sorry?
that's simple.
Well, yeah, it's simple. But even simpler. Right? Note that if we have the integral of f prime x multiplied by f of x to some power n, then once we have it in this form, there's no need for us to go and do integration substitution. All we have to do is this. If this is it here, if it's in this form, then the answer would be f of x to the n plus 1 over n plus 1 plus c. Let's see why, right? Let's see why. Well, let's see how it works. Right. So what you see here, you'll recognize that the differential of this is what? What's the differential of 2x squared? 4x, right? So to make this the differential of this, I should have 4 here, and I should have 4 on the outside, 1/4 on the outside. Yeah. You'll okay with that? So let's see if the rule applies. This is f of x, this is f prime x, and this n. You're seeing that? F prime x, f of x, n. Yeah? So here what the rule says. The rule says if it's in that form, all we have to do is to write, of course, 1/4 on the outside, f of x, which is 2x squared plus 4, n plus 1 over n plus 1. You're seeing that? F of x, n plus 1 over n plus 1. And remember, we had 1/4 on the outside to make these two independent from each other.
Have you got your phone?
Yeah, I did. They are 400 in pounds. Yeah. Okay. So make a note of this, right? Make a note of this. And now we're going to look at cases where it will not work. And we have to apply something else. Alright, ready? So here's what. If integration, you all recognize that this is like a product.
Yeah.
Yeah. So if you get product, right, then integration by substitution cannot work. We use something called integration by parts, right? So if integration by substitution cannot work, we use integration by parts. What integration by parts is that if you have an integral that looks like this, right? The integral is u dot dv. Then to integrate this, it will be u by v. So we need to get u and v minus the integral of v d. Right? I want to show you where it comes from. You don't have to know it, but I'm showing you. Right? But if you get an integral as a product, all you need to do is to find u and v, and you're good to go. Right? But I'm going to show you quickly where it came from, right? If you differentiate ub, what you just get? If you differentiate product, what you will get? And you will get u dv dx. Well, I just put in dv, right? You will get u dv plus v du. Remember that?
Yes.
Yeah? What would happen if I integrate here now? If I integrate the differential of ub, I'll get back ub. Here, I'll get the integral of u dv plus the integral of v du. If I move it across, I'll get the integral of u dv is this minus this. Right? So now we're going to look at integrals that look something like this. And we're going to use this formula here to integrate it. All right? Best way to see it is with a nice example. Suppose I gave you the integral of x sine x. Watch closely. Can we use any substitution here to make this simpler? Sophia, what do you think? No. If we let u equal to sine x, that wouldn't be helpful. If we let u equal to x, that wouldn't be helpful. All right. So what we're going to have to do here, oh, you don't want to write up. What we're going to have to do here is to apply integration by parts. You okay with that? When we do an integration by parts, we have something important. We have a big decision to make. Right? We have a big decision to make. Which one of these is going to be u and which one is dv? Here's how you choose. When you choose, the integral here is supposed to be easier. Right? This is supposed to be an easier integral. You know what I mean, right? This is supposed to be an easier integral than this. So when you choose, this integral is supposed to be easier. If it's hard, then you choose the wrong thing. So I'm going to start the example by choosing the wrong thing. All right? So I'm going to let, actually no, I'm going to choose the right. Right? So I'm going to let x be u, and I'm going to let dv be sine x. What?
Which one are we seeing?
Yeah, I'm going to show you the one. You remember you have to choose. You can either choose u to be this or u to be this. Let's say I choose u to be x, right? Let's see what will happen. The only way I can use this formula is if I find v and I find du. I have u, so can I find du? Yeah? What's the differential of x? 1. What's the integral of b? What's the integral of sine? Minus plus. Remember that? The integral of sine is 9 plus. So now I have u and du. I have dv and v. That's okay? So I'm going to use the formula uv minus the integral of v du. Right? So I'm going to substitute. So I'm going to say the integral of x sine x dot dx is u by v, sorry, u by v, right? Minus the integral of v by du minus cos x by 1. I'm just simplifying this a little bit before I make my decision, right? Minus and a minus plus. Can I integrate this? Cos x? Can I integrate this? What's the integral cos x? Do I have to do anything here? No. That just stays as u by v. That's it. We're done. So the purpose of this is to be able to make the second integral here simpler. Are you okay with that? Adelia? Sure. So Adelia, let's say I did it wrong, right? Let's say I chose here sine x and here's x. The differential of sine x is cos x. The integral of x is x squared on 2. Right? When I come here now, I will get the integral of v du. So I'll get x squared on 2 by du cos x. Is that an easier integral than what we started with? No. So you choose it wrong. Right? I'll also give you an order, right? But generally, you try to make this integral simpler. If not, you choose the wrong thing. Are you okay with that? Okay. Something that you will note about x, when you integrate or differentiate, it'll either become smaller or get larger. Sine and cos, if you integrate or differentiate it, it will just keep it current. When you differentiate sine, you get cos. When you differentiate cos, you get back sine. So they will just keep it current. So it's not getting simpler. So what that means is that you always choose polynomials over traits to differentiate. Okay? Are you okay with that? So integration by parts is used when you cannot, when you have a product and you cannot use substitution. Okay? And then select property. Copy it down. Copy it down. Let's do a few, right? But today the focus is integration by parts. And then we have something after that, but people don't really like for the function. Okay. Big long, yeah. Are you ready? Okay, that's good. Hey, video stuff.
Yeah, I'll go to the, yes, look at the machine going on the.
I don't think they do stuff like. Come on. How I got? So after integrate this, right? I can't use integration by substitution. So the only thing I can use is integration by parts. Right? To use integration by parts, I have to select out of the products, one as U and one of them as DV. Okay, so I choose an X or I choose an sin X. Right. So to work out the rest. Right? So the reason I chose U as X, because when I differentiate, when I find D, you will get 1. And what that does is that makes this disappear. So when you have to integrate V. Right? How do I get V? If you have the integral, sorry, if you have the differential, how you get back the original? Integrate.
Just give it up or something.
So to go down here, we integrate. To go down here, we differentiate, right? Right, so I change it slightly. I give you x squared ln x. Right, so I'm going to ask somebody which one you think will be u and which one you think will be dv. And you tell me why. Right? So the question is which is u and which is dv. Right? Darian. Which one would you differentiate? Which one would you integrate?
Integrate.
Right. Can you integrate on that?
So I got it.
Can you integrate ln x? We can't integrate ln x as yet. So it might make sense to do what with it. Might make sense to differentiate it, right? Yes, you could integrate ln, but I'll show you that now. Right? So in a case where you have ln, you differentiate the ln and you integrate. What's the differential of ln? What's the integral of x squared? X cubed on 3. Right? Now you will get the integral of, oh wait, sorry, try it out. Just take your time and substitute them. I just wanted to give you examples where you had to figure out what to choose. Right? You already have U and V, Samara, and you have DV and D. Right, Samara? Huh? No. Yes. Okay, try it out. So plug it in the formula and it up.
Yes. Something message in my game.
Follow what to do? Victoria? Yep, sure. Substitute, work it out. Clean all, okay? Right? But you follow basic formula. We have U and we have V.
So again,
You're done with that. You have no integration to do there. You have V and you have U. And then you can integrate that. You'll follow why I did not. You'll follow why I did not try to differentiate this and integrate this. We don't know how to integrate learners yet, right? Huh? Yeah. Any questions online? Anelka, all okay? Alex? Amber, following? Huh? Well done? Right, remember you have nothing to do with the U and V. Just leave it as it is. So U is ln x and V is x cubed on 3. So I put in 1/3 x cubed here just to make it look nice. So put it in front, right? Minus the integral, Darion. Minus the integral of V. V is x cubed on 3 and du is. What would happen here? Right? They'll cancel off, right?
Yeah.
So you'll get minus 1/3 by the integral of x squared.
oh,
Right? They'll cancel off, right? And you will get 1/3 x cubed ln x minus 1/3. What's the integral of this? X cubed over 3. And put your plus c on the outside, right? So you'll get 1/3 x cubed ln x minus 1/9 x cubed plus. Yeah? Try the next one. Confused? All right, let's try this now. Try this here. Which one do we differentiate? Which one do we? Because we can differentiate both of them and we can differentiate both of them. But the rules still stand. Second integral and integrals. Right? Okay. Right? What's the integral of e to the x? So the differential of x is 1. The integral of e to the x is e to the x. That's it. What's the actual rule though? What's the actual rule? What's the integral of EF of x? Huh? f of x by now 1 over f prime x. So for example, if you have to integrate e to the 2x, it's 1 over 2 e to the 2x. Right? You gotta remember how to differentiate this? You differentiate the power, put it in front. Remember that? Alright, write it down if you can remember it. It's 1 over the differential of this. So the integral of e to the x, e to the x. Right, not done. Right, so we're going to end up with the integral of x e to the x dot dx is u by v minus the integral of u by this. Right, and that's it. Right, what's the integral of e to the x? E to the x plus v. All right, that not Darian. Esther. Esther. Since we're doing integration by parts, right? How do you think we could integrate ln x using integration by parts? Let's split it up. For dv as no ln x is one thing.
I want to one. I did not see where.
Yes. Maki said flower. Yeah. Adelia, which one would you integrate? So I just put the one to turn it into a product, right? Which one would you integrate? Which one will you differentiate? You have one ln x. Think about it. Can you integrate ln x? So you'll have to differentiate it, right? Can you integrate one?
Yeah.
Go ahead. Finish it up.
You want one?
Finish it up.
What is it? Take a listen. Another dog, yeah, something.
Who's dumpling? Someone who's dumpling.
No.
Right, ln x is what? The differential of ln x is 1 on x. The integral of 1 is x. Right, so therefore the integral of ln x is u by v. Right, if you write it like this, it's always u by v minus this by this. Right, x by 1 on x is what? That's 1, right? So you have x ln x minus, this is 1. The integral of 1 is x. So if I ask you what's the integral of ln, you're gonna write all of this. X ln x minus x. That's okay? Right? Because the x will cancel here and I'll get 1 integral of 1 is this. Yeah? Let's go again. What you will do in a case like this. Alright, now I'm gonna give it up. Yeah, I'm gonna give you one like this. Right. Think it through, right? Right? Let's tell chess. Think 3 moves ahead. Think 3 moves ahead. Select U, select TV. And think 3 moves ahead. And tell no. Right? There's a like something will happen. Something small might happen. Think about it, right? Choose U and choose your TV based on what you learn. And just go like 3 lines down. Here, 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 and see what happening here. Something happening right here. What would you normally choose as you Esther? You sure? X squared, right? You'll normally choose the polynomial here and then put the trigs here. When you differentiate this, what you'll get? 2x. When you integrate this, what you'll get? That sign, right? So now the integral of x squared cos x dot dx, the integral of this is u by v, right? Minus the integral of v by this 2x sin x. That's okay? Can we easily integrate this? Can we easily integrate this straight? Or can we easily integrate this? No. So I just put the 2 outside, right? So you might recognize what happened. What do I do with this now? Yeah, I do it again. So you have to apply integration by parts again. You recognize that?
Yes.
Right? Welcome to unit 2. That's unit 2 then.
Thank you.
Right? Unit 1 might have stopped there. Unit 2 saying, well, yeah, I do this now. Can you apply integration with parts here? Yeah? Samira, you can apply integration by parts here. What would you let u equal to? What you let u equal to here? Right? X and dv to be sin x. Okay? So basically, when you see questions with squared and thing, yeah, do it twice. All right? Yeah? Apply integration by parts here again. No, I think nothing. Class finish in the next question. Huh? Oh, how many?
No.
What the? Tell him what I tell you.
No, but it's problem.
So, for the name of it.
Oh, it's just very important.
Will you question from the first time? Oh, yeah. And we have one more case. Nothing simple. And I'll say how to handle later. So Right, wherever you have the plus in top, put the option, right? Right, so I would say, so the integral of x dot sine x, u is equal to x, dv is equal to sine x, du is 1, v is the integral of cos, sorry, sine is minus cos. So I'm going to plug it in here, u by v, I'll leave my minus sign on the outside, right? U by v minus the integral of du by this. Instead of putting the minus, I'm putting a plus here, right? Plus cos x plus dx. Right? And the final part was the integral of cos x. You just write sine x. You can write plus c, but in the end you'll get one big plus c, so it don't matter. Okay? So now we're gonna substitute it back. We're gonna substitute back in this, right? So I'm going to write equal to, I'm writing back what I had originally, x squared sine x minus 2. And now we're going to include what the integral was, which is this here. So I'll put in a bracket, minus x cos x plus sine x. I'm leaving it out now, putting one big plus c. It don't really matter. In the end, we'll get the same value. So x squared sine x minus 2 by minus is a plus. Plus 2 cos x minus by this is minus 2. Right? That's it. The integral of this is this. Any questions earlier? Just a little bit low, right? I have one more I want to show you. One more type I want to show. Yeah. Hello. Alright? Ready? Right, let's say 1 4, right? Let's take a look at 1 minute. I want you to do that. No matter which one you choose, right? Choose the first one as you and the second as DV. And I want you to do integration by part twice. And tell me what you reckon. No matter which one you choose, right? Choose one as you, right? I'll start it up for you. Choose one as you and choose the next as DV. And I want you to do integration by parts twice. Just make sure e to the x is always u and dv is always the trace. Okay? I'll give you after that. I didn't tell you. Right? Try number 5. Do it twice. Huh? Oh, that's number 4. Right? Do it twice, right? Do it twice, and I'm going to show you what put out. Right, more, that's it, everything 119. 919. Oh, unbeatable. Oh, somebody put it. That might right. That's it. Like, he's my job to run. I don't know. So what you have to do here is you have to apply integration by parts twice, and then I'll show you what to do, right? Some people may have seen it already, but for others, all right, I see something. Show you and do this enough. Anyway, I'll show you next week. Right, so you all recognize that you still have e to the x and sine x here, right? Wasn't much help, right? So when you integrate e to the x sine x, you will get u. Don't change it all, yeah? If u is e to the x, leave it like that. Leave it dv at trig. Right, du is still e to the x, v is minus cos x. Right? And then you work it out, u by v. And minus the integral of e to the x. Right? So when you integrate the sine, you're going to get this. Now I'm going to take it and substitute back in here and show you something really, really exciting. Katie, you don't find this exciting? Oh?
Oh.
So you should reach here. You should reach here. Right? And as Jesse was saying, if we keep going here, we'll just keep going at infinite times, right? But watch it good. Watch this line real good.
So you can yawn.
No, you. Anybody else? Huh? No, you. Somebody else. Anybody else want to try? Huh? Factorize what? What? Huh? Now.
Yes.
Something else you can do. Start the factorization as yet. You can't factorize as yet. But what the question asks you to do? Integrate this, and you all recognize you have an e to the x cos x here. And what you have here? So if I bring it across, no, that's a minus. You'll get the integral of e to the x dot cos x.
Get whatever. Yes.
You'll get two of them, right? And then could you divide by 2?
Yes.
Yeah? That's the exciting. Right? So when you move it across here, you'll end up with this plus this. Right? What you'll do now? Add it up, right? And you'll get 2. So you'll get 2 by the integral of e to the x cos x dot dx is e to the x sine x plus e to the x cos x. I don't have much space, so I'm just going to divide everything by 2 and be done. And we are done, right? If we divide everything by 2, we'll get e to the x dot cos x dx is 1/2 e to the x sine x plus, well, a half by the whole thing, right?
So
Yeah. Hello, okay with it? Tine? Follow what to do? Right, come on the board, last one. I know we have 2 minutes to work it out. Anybody confused? Tina, follow what to do? You make a substitution and then you bring all the integrals on one side. Very good, what's that stuff? Job? Alright? So that's technically what you do. What would happen if you have an integral, right? And it's like to the power of 5. What you have to do? If it's to the power of 2, like x squared, you have to do it twice, right? If it's x cubed, yeah, you have to do it. If it's x5. Right, but you don't want to do that. The shortcut is to create a formula that we call reduction formula. Right, and when you create the formula, you just need to know what kind of. That's what we're doing next. Right? So in order to function next week, we have to be able to. I want to add on like a half an hour next week. And a half an hour the week after, so we can. So when we miss the football game, we're ready to miss one. No, another big style. I was sent the group an hour after, right? Because it's 20 seconds of the game, right? And most of them find goal. But remember the game starts in half 3, we're done by half 5. We by 6 o'clock.
But you that's it. Yeah. And the thing
I look like 3 5 minutes after.
See when you go.
Alright, online. That's it there. When you finish copy it down, you'll fill log out, right? I'll give you